Space exploration is a thrilling adventure. It sparks our curiosity and pushes the boundaries of human ingenuity. We build incredible telescopes to peer deep into the cosmos, and we launch rockets from strategic locations on Earth. In this exploration, we'll delve into these captivating topics. We'll uncover the challenges of building powerful telescopes. Join me on this journey as we uncover the wonders of the universe. Imagine looking back in time, witnessing the universe's earliest moments. That's the allure of building a telescope powerful enough to see the age of reionization. This period, roughly 400,000 years after the Big Bang, marked a dramatic transformation in the universe. Before reionization, the universe was a dark and foggy place. Neutral hydrogen atoms filled space, preventing light from traveling freely. Then the first stars and galaxies ignited, flooding the universe with energetic radiation. This radiation ionized the neutral hydrogen, stripping electrons from the atoms and creating a cosmic fog. This process, called reionization, is a crucial chapter in the universe's history. Observing this era directly is incredibly challenging. The light from these early galaxies is incredibly faint after traveling for billions of years. Additionally, the expansion of the universe stretches the light, shifting it to longer, redder wavelengths. This effect, called redshift, makes it even harder to detect. Building a telescope to peer into the age of reionization requires overcoming immense technological hurdles. We need telescopes with enormous light-gathering power to collect faint photons from the early universe. The James Webb Space Telescope, launched in 2021, is a giant leap forward in observing the early universe. With its 6.5-meter mirror and advanced infrared instruments, it detects light redshifted into the infrared spectrum. Next-generation telescopes will unveil the secrets of the universe's first light show, revealing how the first stars and galaxies formed. Now let's shift gears from the ancient universe to a more playful pursuit: disc golf in space. Imagine teeing off on the Moon, Mars, or even Titan, sending your disc soaring through alien skies. The varying gravity and atmospheric conditions on these celestial bodies would make for a truly unique disc golf experience. On the Moon, with its weak gravity, about 1/6 that of Earth's, your disc would fly much farther and higher. However, the lack of an atmosphere means no air resistance to slow it down or create lift. This means carefully calculated throws and specialized discs designed for the Moon's environment would be crucial. Mars, with its thin atmosphere and weaker gravity than Earth, about 1/3, presents a different set of challenges and opportunities for disc golf enthusiasts. The thin Martian air would provide some resistance, but not as much as on Earth. This means your disc would still travel farther than on our home planet, but with slightly less control. The Martian wind, however, could add an unpredictable element to the game. Sudden gusts could knock your disc off course, requiring players to adjust their throws accordingly. Imagine playing a round of disc golf amidst the rusty red dunes and towering volcanoes of Mars, the wind whipping at your spacesuit as you try to sink a long-range putt. Titan's twist on disc golf. Titan, Saturn's largest moon, offers perhaps the most exotic disc golf destination in our solar system. This frigid world boasts a dense, nitrogen-rich atmosphere and even weaker gravity than the Moon, about 1/7 of Earth's. On Titan, your disc would soar through the hazy orange sky, staying aloft for extended periods due to the low gravity and thick atmosphere. However, the dense air would also create significant drag, requiring powerful throws to achieve distance. Playing disc golf on Titan would be like playing in slow motion, with the disc gracefully gliding through the sky. Imagine the thrill of watching your disc descend through methane rain clouds, landing softly on the icy surface of this alien world. Riding Earth's carousel into space. Launching rockets is a complex and expensive endeavor. Every kilogram of payload sent into space requires a tremendous amount of fuel, and even small efficiency gains can make a big difference. That's why we launch rockets near the equator whenever possible. Earth's rotation provides a natural boost to rockets launched eastward near the equator. Think of Earth as a giant spinning carousel. The closer you are to the edge of the carousel, the equator, the faster you're moving. Rockets launched eastward from the equator get a speed boost from Earth's rotation, helping them reach orbit more efficiently. This speed boost translates into significant fuel savings or, alternatively, the ability to launch heavier payloads into space. For space agencies and companies operating on tight budgets, this equatorial advantage is crucial. Equatorial launch sites, gateways to the cosmos. Several factors influence the selection of a rocket launch site, including safety, accessibility, and political considerations. However, the equatorial advantage is a major factor, leading to the establishment of numerous launch sites near the equator. Cape Canaveral in Florida, the iconic launch site for NASA's space program, benefits from both its proximity to the equator and its location on the southeastern coast of the United States. Launching eastward over the Atlantic Ocean minimizes risks to populated areas in case of a launch mishap. Other notable equatorial launch sites include the Guiana Space Center in French Guiana, used by the European Space Agency, and the Satish Dhawan Space Center in India, operated by the Indian Space Research Organization. These strategically located launch pads exemplify how we leverage our understanding of Earth's motion to enhance our spacefaring capabilities. The future of exploration. As we continue to explore the universe, we'll undoubtedly develop even more powerful telescopes, allowing us to peer deeper into the cosmos and unravel the mysteries of the early universe. We might even find ways to send robotic explorers or even human astronauts to play disc golf on other worlds, turning science fiction into reality. The quest to explore space is a testament to human curiosity, ingenuity, and our unyielding desire to push the boundaries of what's possible. By harnessing our understanding of the universe, from the laws of physics to the celestial dance of planets and stars, we're unlocking incredible opportunities for discovery and adventure. As we venture further into the cosmos, one thing is certain: the future of space exploration promises to be filled with wonder, excitement, and endless possibilities.